So I'd like to introduce John Walsh from Northwestern University, and feel free to tell them what you think.
Hello. Well, first of all, you hear about Northwestern University, you probably think about, oh, we're just here to talk about all academic stuff and everything we do. However, Northwestern is also a large corporation in the sense we do run ERP systems, we are running a PeopleSoft environment, we're running a Blackboard environment, but ironically what drove us to going to Tintri was a vCloud environment. So what we ended up doing is we've got a lot of distributed schools and departments that make up Northwestern that have their own little data centers, their own little pockets of vSphere clusters, vSphere, VMware View, you name it, categories. So we decided to implement vCloud and provide infrastructure as a service out of the data center. So about a year ago, we started investigating vCloud. We brought in the Weinberg's College of Arts and Sciences, Northwestern University Library, got them together, architected a governance committee to start running an internal private cloud. And when we started looking around for storage, we decided we wanted to do a pod-based architecture, extend out on our VM environment we currently have, taking a little step back in what I was talking about, our virtual environment. You have a question, Nigel?
What is cyber infrastructure?
What is cyber infrastructure?
Fabio asked me. Well, he pointed it
What
out.
is cyber infrastructure? That is a good question. It's secret, we can't talk about it. No. There is a group in the National Science Foundation, and in the research side of cyber infrastructure composes everything that's storage, networking, computing together in this whole cyber infrastructure group. So what I actually do, and I should have gone back a little bit here and say my official title is Manager of Processing and Information Platform Services. So that's really basically a fancy way of saying processing. I'm in charge of the servers and the storage groups. Physical and virtual. Information platform services, information part. I've got the direct attached storage, the SAN storage teams, the high performance computing research environments under me. And then cyber infrastructure is the subgroup of Northwestern University IT.
Didn't want to derail it.
That's
Just
okay.
it's quality
That's okay.
wording.
I know, it's such a cool, saying, hey, I'm in cyber infrastructure.
I would just put manager of cyber infrastructure.
Now I get in trouble because I'm actually processing and information management.
Yeah.
PIPS is a side group of it. At least they didn't call us pimps.
So
but
he manages the cyber.
But
they thought about it.
they thought about it, yes.
You're basically Gladys Knight.
That's right.
Well, there is well, no, we won't go there. But yes, I could be Gladys Knights, and I've got a bunch of pips working for me. But they're probably watching me now, shaking their heads. So. I may get stoned when I go back to work on Monday.
Well, it's a college, so that means something.
Yeah. So,
as the Dutch guys in the room can attest.
yes. So essentially, our journey in VMware started back in the 2005 days. We started out with the good old GSX 2.5. Started playing with that a little bit. We had expanding need in development environment. Decided we needed a cluster when ESXi, or not ESXi 3, ESX 3.0 built the cluster, rolled up to ESX 3.5. Like a lot of people stayed on it a long time. It was kind of like the NetWare 3 of its day. We just stayed on it a while. About a year ago, we skipped 4.0, completely jumped into 4.1, and just finished rolling over from 4.1 ESX to ESXi. And bringing new clusters, we're going to start bringing in the 5 flavor, 5 update 1. We've got new hardware coming in. But what we were doing is we wanted to build this cloud. We were determined we wanted pod-based architecture like we do in our vSphere clusters. We are a Dell shop, so we decided we wanted to use Dell components. We wanted to have predictable costs, scalable efficiency. Our model has been scale up. We are, IBM, EMC, Isilon in-house, so traditionally our environment's a high-performance computing environment. It's been a scale up. The research computing scale up, the VMware clusters we do, as Kieran described before, we need more capacity, we add another server. So we built the pods, threw in 4 Dell, today they're going to be our 620 servers, and decided the best fit after looking at stuff out there like EqualLogic. I didn't want to go iSCSI. We have a lot of fiber channel in the university. I've got on the floor probably about 1.5 petabytes of spinning disk. Usable capacity is not quite there. We have Isilon for our big data, some of the research sets. We originally bought Isilon in when they were just out of the startup mode for streaming video. So we wanted something that we could have this containerized pod, 4 Dell servers in it, a storage device, and a contained networking. And also we added in, we're a VM shop for our data protection on the backup and recovery side. So we wanted to add in a backup and recovery pod, so basically a a DAS model for a compute node to do the Veeam backups with. So what we ended up doing is looking at everything, trying to find out what fit best with vCloud. Well, since there's such an abstraction between vCloud and the LUNs you give it behind it and traditional storage array, and losing the aspect of where is this VM somebody's just created in the cloud, is it going to live on LUN 1, LUN 2, maybe vCloud director is going to decide to split it off. We decided pretty early on we wanted to go NFS with it. Didn't want to deal with iSCSI, didn't want to bring in a completely different storage protocol. There's been a lot of NFS in the university from the Isilon side, a lot of NFS from the research computing side. So I believe it was in the July VMUG, I ran into Tintri, Justin, and Kiernan at the Indy VMUG and started really getting interested in the Tintri product and looking at how this was going to be a fit. At the time they had the T445, they were talking about the T540 coming out with the dual controllers, which for us, active standby or some sort of redundancy on a controller is very, very attractive. So that was one of the key flavors for us in the T540. It was 13.5 terabytes of usable storage. Well, we threw that in. As soon as it became available in October, we got in an evaluation, started digging with it. Our cloud environment, the proof of concept started in April, officially ended in September, but we reopened it up, brought in some workloads, threw it into the cloud, and threw it on the Tintri storage appliance. What we like about it is I've got 2 SAN admins for all that spinning disk, the backup infrastructure. We got IBM LTOs, robotic tape libraries, and an MDS SAN. So those 2 guys stay pretty busy. I wanted the vCloud, since we're providing infrastructure as a service to schools and departments, I wanted a homogeneous package that the vSphere admins could work on and basically self-deploy. And I didn't want a lot of staff time spent with tuning LUN, presenting LUNs, managing LUNs, based on the fact that we're providing this out as a service to the schools that in turn are becoming a service provider their own to their end user customers. So the T540 and the Tintri product was a natural fit. Not to mention the fact is we knew at the time we were going to get calls saying, hey, my VM's slow, my VM's got problems. If I wanted to throw these sorts of resources behind it and I'm doing a pod-based cloud architecture, how do you scale up to deliver the IOPS, in a tier 1 storage platform without doing a scale-out model in this sort of appliance? We'd have to look at, God forbid, short stroking LUNs, throwing a bunch of SATA drives into it, making it cheaper, and then try chopping it down to get the IOPS you need. Comparing this to our VNX array, we typically run 30 disk, 600 gig fiber channel, 15K storage pools out of that. So if we just do average math, you're talking a maximum of 6,000 IOPS. Best case capacity on it. On this thing in evaluation mode, doing some end-to-end testing, and when we first put this in, we were running on 1 gigabit Ethernet. We were driving up VMs at 30,000 IOPS doing IO load testing on it over gig Ethernet, no degradation, very minimal saturation on the 1 gig. We still had room. We could have pushed it up more. I mean, my limitation was the network. I could not sync the box. So we tested all kinds of various workloads in the cloud. The use case for the tenants in the cloud is there's some people doing Drupal development. They're looking forward to the fast provisioning features in vCloud, being able to create a gold master of a web app deployment and then just basically scale it out and be able to transport them in the future to hybrid cloud, move them out into EC2 or wherever they may be in other academic institution. The other workload we have in their schools and departments have a lot of homegrown applications. They have many different web applications, many different customized applications. Some cases they're running labs, their own internal labs for researchers, research survey sites. So the workload we're going to have in this was very diverse. The other thing we found out in the case is the library does a lot of digital imaging. They are part of the Fedora project with the Library of Congress and Carnegie Mellon and a few other institutions. They're looking at taking their VMs that live in our traditional vSphere hosting environment and starting to putting them over in the cloud so that they have this end-to-end management. So what we're able to do in this that I'm not able to do in the traditional vSphere environment and our traditional hosted vSphere environment is we can pinpoint, as you saw on the dashes, as Ed demonstrated, somebody calls up and says, my VM's slow. We can actually go into the dashboard for the Tintri appliance and we can sit there and say, why is your VM slow? Do we have network latency? Do we have storage latency? Is the hypervisor being stressed? You know, true, it's a pure cloud infrastructure as a service model, so we don't want to sit there and manage and micromanage every VM because they're deploying them ad hoc out of the service catalog. But it's definitely a feature and a function that we wanted to be able to get that visibility into, especially with vCloud abstracting everything. And if it was in a traditional LUN approach with 1 or 2 terabyte LUNs attached to it, these VMs could end up on different LUNs, and trying to track down the performance on it was quite tricky. Because originally in our proof of concept, we did just deploy several 1 terabyte LUNs on the SATA side, several 1 terabyte lines on the pure fiber channel side, and some in from the SAS side and the VNX, and did some usage analysis. And what turned out to be the best bet and the best mix was throwing it on the Tintri appliance, because we didn't really have to worry about pools. We didn't have to worry about...
On the old vCloud, you can't even really balance. You can't pick,
right. You can't pick it, exactly. And the thing is, and even with the newer ones, it's a little more... 1.5.0 and 1.5.1 is a little more aware. Future versions are coming out with some more features this summer that make it a little more visibility, but still, this is still the best bet, because as you saw, there's performance overhead on here.
Why did you only pick 4 hosts? Is that just your decision, or
we picked 4 hosts because we ended up going with the R620, so I got the Sandy Bridge architecture. We ended up going 256 gig of RAM a host. And looking at the use case model, we figured we were going to be running between 144 and 300 VMs on those 4 hosts, depending on how big the VMs they deploy are. In the case of the library, there are probably going to be fewer larger VMs. In the case of Weinberg, they could be many smaller VMs for web app development and research websites and stuff that those researchers put out. So it just turned out to be a nice cost-based pod model of the 4 hosts, because we essentially take our cloud pod, make that into the provider VDC, and then as we bring tenants in, we turn them into the org VDCs. So in that provider VDC, we're going on the newer model, like what Duncan Epping and Chris Colati and basically have mentioned, that put your vCenter into your management cluster, have that vCenter manage that specific vCloud director, and keep all your other workloads out of it. And that also gives us the ability, with that smaller host and that smaller capability, to add in more pods, bring in other schools and departments that want to come in. Because when we started going around and querying people and seeing what their interest was in coming into the cloud environment, the interest is greater than the capacity we can fulfill. I mean, we're just rolling this out, but trying to figure out the funding model and the governance for it is a little difficult, because today we do a showback on the traditional hosting environment. So we don't sit there and say, you want a VM, it's going to be X amount of dollars, we just give you a VM. So the cloud model is looking a little bit different. These schools came in, funded it, and we wanted set cost, predictable future of, we don't want to add a host into the pod and scale the pod up, we want to scale up by a pod unit. So the way we have it set up with the Veeam Protection Pod, the T540s, and the R10s, essentially 2 pods of consumer rack. So we can go, just have it scaled up in a consumable model.
How big is your management pod? Is it 4.2?
The management pod we're taking out of the traditional vSphere environment that the rest of the data center's in. In the Evanston data center, which is our primary data center, we have today about 1,200 VMs and about 40 ESXi hosts in it. Due to our scale-up nature, we're typically been RAM challenged, like most people, not CPU challenged since the Halo architecture came out. So we've been chopping down from, originally we had the 4 CPU boxes, the R900s, R910s, and we decided the R710s and R620s suited us better. The 720s, or the 710s and 720s we went with on the traditional environment, because I've got 2 HBAs in there and I got 2, well today we're doing a data center network refresh, so the majority of the data center is still on the 1 gig, the cloud pod is on the 10 gig, Juniper 4500s. We're still yet to be determined on what the future data center may hold. We're looking at Juniper, Arista, Cisco, Force 10, IBM networking, etc. Just trying to find the best of breed, best integration. So it was more of a predictable cost, a predictable model of scalable expansion. You could very easily, depending on your architecture need, make an 8 host pod, a 10 host pod. Put in more T540s. We still haven't quite figured out what the need might be for like a tier 3 storage of a big raw backend for file services and stuff like that.
Yeah, it sounded like the library was going to do that.
Yeah, well, the library, I saw you guys talk to it, Dell DX today. Dell DX is one of the partners with the Library of Congress and Carnegie Mellon and University of Illinois in doing object-based storage, because their Fedora project specifically takes all those library catalog attributes and throws it into the file system, into that object. But that's a whole different beast. The front end workflow, the ingest and everything else, they're going to have living on the Tintri and doing the image processing and stuff on that point, and then throwing it in the repository for long-term archival. I mean, one of the ultimate goals is to try to have this repository of images and sources at the university so that every group and every website isn't having their own copies of these same entities and objects out of, you know, copied over to their individual web servers. They can go to the main repository and check out or display those images.
If you said earlier on that you already had Fibre Channel and NFS as an IP protocol, it kept you from looking at iSCSI solutions. Would it be the other way around too? If you had iSCSI, would have kept you from looking at NFS solutions?
I don't know if iSCSI would have kept me from looking at NFS solutions. One of the main reasons why we really didn't go down the iSCSI path is because we had 2 gigabit and 4 gigabit fiber channel. 2 years ago, we did a complete fiber relay in the data center. We did large expansion of power and cooling in the data center, new racks, LED lighting. Right now, we're working on cold aisle containment, energy efficiency. And we just have this vast fiber channel infrastructure. It didn't make sense to go to it. And at that point, looking at 1 gigabit fiber channel at the time, or 1 gigabit iSCSI at the time versus 2, 4, 8 gigabit fiber channel, we just didn't see the need. But then if you could jump into 10 gig NFS, not to mention have one single data store, not worry about locking, not worrying about how many VMs you can have on it. I mean, the attractiveness of NFS was there.
So it was more than just having already an IP protocol.
Exactly. It was more than that. It just made sense at the time. I mean, if you had iSCSI today, bringing NFS is kind of a no-brainer. It's an easy mix. I just didn't want to sit there and say, we're fiber channel huggers. We are open. Our research environment, we've got GPFS running on direct attached storage. I've got InfiniBand running in the data center. So, we've got all flavors of storage. Isilon, we're serving up video streaming content. We're streaming up research computing off the Isilon and general purpose file services. And, one of the big things is, today, if somebody wants a file server, we're typically just throwing that on a VM and throwing the back-end stores for those file server mount points on SATA disk somewhere. And kind of the understanding is in the cloud, there probably wouldn't be a lot of those file services put there. It's going to be more the application-based. Now, one of the other things that we did do is, yes, we bought this in for vCloud, but we also put one of our critical enterprise systems on there, the Blackboard course management system. We wanted to test out how things were going on it. Well, it was living on basically a 30 disk to 600 gig fiber channel pool, getting about maximum in that pool 6,000 IOPS. We popped it on the T540. It's one of those large VMs. The Oracle database on the back end of it's over 1 terabyte. There's about 1.5 terabytes of NFS file services on it. Think of a whole metadata relationship with a web app front end into it. So basically, you log into a class, you're a student, you come in, you get your syllabus, you get your courses, you take your quizzes, you do everything else on it. We popped it over in the T540 as we're doing some storage migration, so we just SV motioned it over in there. We had to do the updates on our VNX, moved it over there. Watch the performance go up dramatically. There is a daily job that was running that is running 45 minutes later that basically does an integrity check every morning. It goes in and sits there and says, checks every object in the file system, on the NFS file system, compares it to the database, and sees if there's anything missing. And what's wonderful on the T540 is the burst capacity on this thing. So you're limited kind of that 6,000 IOPS maximum. This thing can spike up on that single job. It can be running in the 200 to 400 IOPS and all of a sudden spike up to 6,000 IOPS, 8,000 IOPS as it runs that job and just drop back down. So where our limitation,
So you never moved it back, and nobody will let you.
Well, yeah, we're kind of in that boat. It's if I had magic funding right now, we're on a fiscal year that starts up to September 1st. So if I had that magic funding right now, I'd leave Blackboard on the Tintri without a doubt. I mean, especially with the future cloning stuff coming out, because basically doing an rsync, doing an Oracle database, an RMAN backup and a clone and a snap and lining everything up with data and metadata is a timing nightmare. But if I could sit there and clone them out like that, run out a copy of the production system, the QA system, because Northwestern also does development for Blackboard. They did they call it Baboogle. It's the Blackboard Google integration where they took Google Docs and brought it into Blackboard so that you could extend the two across each other. So there's a team at Northwestern that has to maintain that, so of course they have a test system for that. What you don't see in the Blackboard system is you see 3 terabytes live online data. You don't see the 5 to 10 terabytes sitting on the Isilon in the back end for 5 years worth of archives that they course life archive, because we don't want professors to have to keep uploading courses. But every upgrade becomes a nightmare because you're processing through 1.5 to 3 terabytes of data every time.
So can I just ask a general question, not necessarily? Sure. So typically, how many boxes do customers buy?
It ranges between some buy 1 box, others have bought 6 boxes, and so it depends on the load. One of the things that we see is that people start out buying a box or multiple boxes or a couple of boxes, and then they find some other department or some other location that actually wants their own and then goes.
So if they buy
What's
one
the
box,
second sale percentage?
The second sales percentage, I mean, it's still early. We're still.
It is still early.
Yeah.
Howard, to give you an example, in my batch, 66% of my Q1 sales this year were from return customers. So
Okay,
I have a pretty high hit rate. I don't know about everybody else.
But that's the number I'm looking for.
Yeah.
Because for this kind of product, nobody is going to buy 10 all at once. Everybody's going to buy 1 and see how it works, and the next order might be for 9. But nobody's diving that deep in the ocean.
And I can honestly say, if I could replace more storage with Tintri on the VMware side, I really would.
Yeah.
Just based on the visibility you get into it, the ease of manageability. I've got the storage admins hovering over the VMware admins, amazed at the metrics they see on it.
Right.
They're sitting there going, we got our 24-hour snapshots out of the MDS framework and DNCIM and stuff, and they're like going, man, we don't get this detail, in the sand.
Well, I think that most of those storage admins, I mean, apart from spending this much money just on metrics collection, that's the only way they could get this number. So, well, we've got to wrap up. Let's let Kieran.
Yeah. So just very quickly, so there are a lot of technical resources on the website that you can look at. I think probably some of them are in the materials that you have. So we didn't even go into things like data integrity, which is actually very interesting in itself. But if you just get 2 messages from this, it's it's Flash and VMware, and we're in use at many customer sites. So thank you very much. Very good.
Yes, thank you guys.